beginning our review video for section 6.6. That's chapter 6, the 6th section. And as we look at, like we do every time, we always start with our learning target. So we're going to graph the reflections on a coordinated plane. We need some definitions before we can do that. We're going to learn what a transformation is, a reflection is. A reflection is a type of transformation in which a mirror image is produced by flipping a figure over a line. A line of reflection is a line that is flipped over, is the line that the figure is flipped over in a reflection. We're going to be dealing with symmetry here. The transformation, a mapping of the geometric figure, and the image is the position of the figure after a transformation. Well, I'll jump right in and do an example here. Copy the trapezoid STUV below on a graph paper, and then draw the image of the figure after a reflection over the given line. The given line is right here. So that's going to become our axis of symmetry that we learned about in the last section. And what I need to do is transpose this diagram on this side, so it's the same diagram on the other side by just flipping it over. And so I'm going to move S, the same unit, away from the axis of symmetry and call that S prime. I'm going to move T, 1 unit, 2 units, 3 units, well, 1, 2, 3 units, 1, 2, 3 units. So T prime would be right there. 1 unit, 2 units, 3 units again. 1 unit, 2 unit, 3 units right here for U prime. And V would be just 1 unit, V prime. So as I connect this, the reflection, it's reflective about the axis of symmetry, which is right here, and it's just transformed. Please notice that the values of the x, y for, say, S, the value for x and y here, the only thing that changed was the y value. The y became the opposite symbol, if this is our y-axis. This point right here is our y-axis. Let's do another one here. Looking at this diagram, triangle or trapezoid T, P, A, and R. I'm going to graph it by moving over. I'm going to move over 2 units here, 1, 2. That becomes T prime. Move this over 1, 2, 3, 4, 5. So it's 1, 2, 3, 4, 5 is R prime. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's point A prime. And P is 1, 2, 1, 2. P prime is right here. So the reflection is like that. Which one of these diagrams, A, B, or C, would match that? Well, it's not A because they've got T higher than the R, or the, so this one's not correct. This one's not correct because it's on the axis of symmetry. This one looks pretty good. I do need to check here. I think this has dropped 2 units here instead of 1 unit, so it's got to be answer C is the correct answer. C is the correct answer. Do this one on your own. Transpose this one around the x-axis. It's going to be the same thing, but since we're going around the x-axis here, we're going to take the drawing up here and flip it to down here. So G is 1, 2 units up, so now it becomes 1, 2 units down. This is G prime. F is 1, 2, 3 units up, so it's 1, 2, 3 units down. Notice I'm keeping my x values the same. I'm just changing to the opposite of the y values, the opposite of the y values. Plus 1 for y, minus 1 for y. Plus 1, 2, 3, 4 for the e here becomes 1, 2, 3, 4 for the negative e, or e prime. All right, so if I connect these, missed there a little bit. Do those look symmetrical about the x-axis? And other than my drawing error, they do. So notice that we changed the y value in each case to the opposite value if we're flipping it across the x-axis. Graph the quadrilateral with the vertexes at 2. Well, Q is 2, 4. U is 4, 1. Negative 1, 1. Negative 3, 3. And then graph its image. All right. We'll do just a quick sketch here. I've got Q is at 2 and 4. I've got U is at 4 and 1. I've got A, which is at negative 1, 1. And then I've got D, which is at negative 3 and 3. So if I connect all those, and I'm going to draw the image after reflection over the x-axis. So the x-axis, which means I just changed my y values. So my Q prime is going to be 2, comma, negative 4. U prime is going to be 4, comma, negative 1. A prime is going to be negative 1, negative 1. And D prime is going to be negative 3, negative 3. So I'm going to switch colors here and try and do that. 2, negative 4 becomes Q prime. 4, negative 1, 4, negative 1 becomes U prime. A prime becomes negative 1, 1. I'm sorry, negative 1, negative 1. And D becomes negative 3, negative 3. Probably a little bit closer to there. Again, hopefully the symmetry, you can see the symmetry across this line, that the green drawing down here looks very similar to the red drawing that's up here, and if I'd done it on graph paper, it should have come out exactly the same. We have a graph the quadrilateral of A, B, C, and D with vertices at 1, 3, 4, 0, 3, negative 4, and D, negative 1. It's already done here for us. Then graph the image of the triangle or of quadrilateral ABCD after reflection over the y-axis. This time we're flipping it over the y-axis. So if we're going to flip over the y-axis, the y values stay the same, the x-axis becomes a negative. So A prime becomes negative 1, comma 3. I'm keeping the y value the same and changing to the opposite of the x value. B prime becomes negative 4, comma 0. C prime becomes negative 3, comma, negative 4. And D prime becomes negative 1, comma, negative 2. All right, so let's graph this one. Let's start with A prime, negative 1, 3. So negative 1, 1, 2, 3. A prime. B prime is negative 4, negative 1, 2, 3, 4, and 0. It's B prime. C prime becomes negative 3, 1, 2, 3, and negative 4, 1, 2, 3, 4. That's C prime. D prime becomes negative 1, negative 2. So if I connect these, I should have a symmetrical drawing to the original one. I'm sorry, I've got to erase that last one. Correct that. Hopefully those drawings are very, very similar. Quadrilateral with vertices at 2, 2. 5, 0, 4, -2, and D is 2, -1. The graph of the image of ABCD after reflection over the y-axis, again, it's over the y-axis. So write the coordinates of its vertices. A prime, since I'm going over the y-axis, the x-axis value changes to its opposite. A prime becomes -2, 2. B prime becomes -5 and 0. C prime becomes -4, comma, -2. And D prime becomes -2, comma, -1. This is to be reflexive over the y-axis. The x values change. I'm not going to graph that. I'm confident that you can graph both of those. Copy and complete the office floor plan shown below so that the completed office has a horizontal line of symmetry. Horizontal line of symmetry is the red dotted line, or in effect, it's the x-axis here. So I'm just going to start copying. Just go the opposite direction for the for the y value, but keeping the x values the same. Three, 4. So this point right here, not a very good oval, sorry about that. And given other than graphing errors, I think those are symmetrical across the horizontal line. This drawing would be very difficult to complete without the idea of symmetry, but I'm going to start doing the green parts. So it's going to go straight across 1, 2, 3, 4, 5, 6, 7 boxes. 1, 2, 3, 4, 5, 6, 7 boxes. Drop down, and it also goes straight across. All of this would be colored green. Back 1, 2 boxes. And again, I'm just copying the green at this point. You can see I made a little bit of an error here. Only went that's a little too high. switch and do a little bit of blue here. And you can see I'm just going along and duplicating the drawing from one side to the other. All right, I think we can finish it now. Whoops. And I made a little error, it looks like there. But I think if we colored this in blue, we'd be very close to the original drawing. I can see I made a little error up there too. But all right, very close to the original drawing.